In this screencast, we discuss the properties of the real numbers. In order to correctly interpret expressions like 2 times 9 minus 16, and even longer expressions like this, it's essential to understand the order in which the mathematical operations are assumed to be performed. In fact, to simplify an expression like 2 times 9 minus 16, all you need to know is the order of operations. However, to simplify an expression like this longer one here, you're going to need additional information, specifically some basic properties of the real numbers. In this screencast, we study these properties, and they're listed on the next page. For any real numbers a, b, and c, the following 5 properties are true. Let's look at the first one. A times b is equal to b times a. This property says that you can multiply two numbers in any order you like. This is called the commutative property of multiplication. The second property says effectively the same thing, but in this case for adding. If you add two numbers together, you're free to add them in the opposite order. And this is called the commutative property of addition. Let's look at the third property. This concerns 3 numbers that are multiplied. Now, when you multiply 3 numbers together, generally you multiply 2 of them together first, and then take your answer and multiply by the third. In this case, the numbers b and c were multiplied together first, and then the answer was multiplied by a. The associative property says that you could also calculate this product by taking a and b and multiplying them together first, and then taking your answer and multiplying by c. In general terms, the associative property of multiplication says that whenever you've got 3 numbers and you're multiplying them, you can choose any 2 of them and multiply them together first, and then multiply your answer by the third number. Next we come to this property. Again, it concerns 3 numbers. In this case, you're adding 3 numbers together. Typically, when you add 3 numbers together, you add 2 of them together first, and then you add the answer to the third number. Well, on the left side here, the numbers b and c are added together first, and then a is added to the answer. The associative property of addition says that you could also have just added a and b together first and then added c to the answer. So effectively, this property says that when you're adding 3 numbers together, you're free to add together any 2 of them first and then add the third number to your answer. The final property is called the distributive property. In this property, it involves both multiplication and addition. On the left side, we have a number a that is multiplied by a sum, b plus c. The distributive law says that you could calculate this in an alternate way. Instead of multiplying a by the answer, b plus c, you could instead multiply a by the b, that's this part, multiply the a by the c, that's this part, and then add the 2. So instead of multiplying a by the answer, you're multiplying a by both the b and the c, and then adding your 2 answers. Of these properties, the commutative and the associative properties are probably fairly intuitive to you, but what about the distributive property? Let's try to make some sense of this property. So let's look at example 6.3. According to the distributive property, 8 times 3 plus 2 is equal to 8 times 3 plus 8 times 2. Let's check that this is actually true. We can do this by looking at the left side of this equation. That's 8 times 3 plus 2. Let's calculate it. Using order of operations, this would be 8 times 5, which is 40. So the left side of the equation is 40. Let's check to see if the right side of the equation is 40. 8 times 3 plus 8 times 2. Order of operations says we do the multiplication first, so we would get 24 plus 16. Adding gives us 40. So you can see the left side of the equation and the right side of the equation are equal. Now let's think about this example in context. Suppose that Eleanor and Stacy were two teachers and they have several packs of dry erase markers to use in their classes. Each pack of markers has 8 markers in it. And let's suppose Eleanor has 3 packs and Stacy has 2 packs. Let's write down 2 equivalent expressions for the total number of markers owned by the 2 teachers. So if we wanted to calculate the total markers, there's a couple of ways we could do it. We could figure out how many markers Stacy has. Well, let's think about it. Stacy has 2 packs of markers, and each pack has 8 markers. So Stacy would have 8 times 2 markers. Eleanor has 3 packs, so the total number of markers Eleanor has would be 8 times 3. So that's one way of calculating the total number of markers. There's another way. We could figure out how many packs total the 2 teachers have, which is of course 2 plus 3. So that's how many packs there are total, and each pack has 8 markers. So that's another way of calculating the total. We've just illustrated in this example why 8 times 2 plus 8 times 3 should equal 8 times the quantity 2 plus 3. This is precisely what the distributive law is saying. Now let's continue down to the next example. Example 6.4. Rewrite each of the following expressions in an equivalent form using the distributive property. Simplify if possible. The first one's been done for us. So just a reminder, the distributive law says that if you have a number times a sum, you can calculate the answer by taking the number A, multiplying it by the B, and then taking the same number A, multiplying it by the C, and then adding. So let's apply that to this example that's already been worked out. 6 times the quantity 2 plus 7W. Well, if you look at this quantity right here, it is precisely in this form. You can see that the 6 is playing the role of the A, the 2 is playing the role of the B, and the 7W is playing the role of the C. So if we want to write this in an alternate form, we would write it in this form. So remember, the 6 is playing the role of the A, 2 is the B, 7W is the C. So I write it in this form as follows: 6 times 2 plus 6 times 7W. Now we can simplify. 6 times 2 is 12. And here we can use the associative law. We're multiplying 3 quantities together. We can choose to multiply any 2 of them first. So we can multiply the 6 and the 7 and get 42, and then multiply by the W. So this would be our simplified version. Now let's move on to B. In this case, you can look at this expression and compare it to what we have here. You can see that the 5R is playing the role of the A, the 9R is playing the role of the B, and the 2 seems to be playing the role of the C. There's one difference though. In the distributive law we have addition, but in this example we have subtraction. But as you know, every subtraction can be rewritten in terms of addition. We can rewrite this as 5R times 9R plus a negative 2. So you can see here that really the negative 2 is the C. If we apply the distributive law to this, we would rewrite this expression as 5R times 9R plus 5r times negative 2. Now let's simplify. This expression, this term right here, is the result of multiplying four quantities together. We have 5 times r times 9 times r. The associative property says and the commutative property together tell us that we can multiply any two of these together. So we'll multiply the 5 and the 9 together. That will give us 45, and we'll multiply the two r's. That will give us an r squared, plus. Now we multiply here. Again, the associative law and the commutative law of multiplication tells us when we're multiplying these numbers, we can choose any two of them to multiply together first. So we'll choose to multiply the 5 and the negative 2. That, of course, will give us a negative 10 times the r. Written in its simplest form, we would write this as 45r squared minus 10r. Now let's look at C. If you look at the expression that's given, it's not in this form. In fact, this expression is actually given in this form. How can you tell? Well, this expression is the sum of two terms, and notice that each term has a common factor inside it. Well, let's look at this expression. There are two terms, and notice that each term has a common factor of 2 inside it. We can write it so that this is a little more clear. We'll write this as 2 times 3 plus 2 times 5y. So you can see the 2 is playing the role of the a. So we can rewrite this in an alternate form using the distributive law. Instead of writing it in this form, let's write it in this form. So I'm going to bring the 2 outside, that's my a, and then inside the parentheses I should have the b plus c. For us, that's 3 plus 5y. And that would be the simplest form I could write that in. Now let's look at part D. This quantity is also in this form. We need to identify the a. What is the factor that is common to both of these terms? Well, 4 is a factor of the first term, and notice that 12 has a factor of 4 inside it as well. In fact, we could rewrite this as 4y plus 4 times 3, so that you can see that there's this common factor of 4. The 4 is playing the role of the a. So we're going to rewrite this expression in this form. Let's go ahead and do that. The 4 will go out in front, and we're left with y plus 3. Now let's look at part E. Again, this quantity is written in this form. Notice also that there is subtraction instead of addition. So let's take the initial step of rewriting this as addition. Okay. Now, the next step is to identify a factor that's common to both. You can see that both of them have a w, but there's also more that's common. 6 has a factor of 3 inside it. So does the negative 15. And in fact, we could rewrite this as 3w times 2. Let's think about that. 3w times 2, if we multiply that back together, that would give us 6w. So this is the same as this term here. Let's continue. Plus 3w times negative 5. This quantity here is the same as this quantity. So writing it in this form, I can see I've got a common factor of 3w. Now I can rewrite this in this format. The 3w is playing the role of the a. Oops. And then I'm left with 2 plus a negative 5. Let's simplify. This would be 3w times a negative 3, and if we multiply, we will arrive at a negative 9w.